Okay, I guess we are live. Let me check once again. Okay. Um, let's start now. Yesterday we had a very major problem that our model was even detecting nominal data as um, anomaly, and our Gemini, we went to Gemini then, and our model tells us that uh, mm, here some of the things. Okay, my mouse, why is it being so weirdly, bro? My mouse is behaving weirdly, total weird. I don't know. Okay. Now, okay. Now, okay. Your model flags nominal data with a confidence score as high as 0.99 is a classic case of ground truth disagreement. It doesn't necessarily mean your code is broken. It often means your model has learned a pattern that human laborers choose to ignore. Based on my analysis of your test and CSV and the project file, it is why you are exactly seeing this error. The A3 label paradox. In your test, the column anomaly is 0 nominal, but the column label is A3. The experts use the ASI and label this segment as 0 because they are not severe enough to notify an operator. Okay. The model view. During training, the SN and saw many other segments mm, that were labeled as anomaly. Your model is detecting the A3 behavioral segments, even though the physical ground is not nominal. Feature mismatch. Okay. The conflict. Your model is detecting the A3 behavioral signature. Specific jitter or slope with 90, but it was a labeled data, man. How will it, how is it possible? uh, Feature mismatch. When I compare the feature of segment 5 in the setting which feature extracted by your live code, I found a significant mismatch. The official row for the segment gap score means there are several zero values. Your 160 point window has currently gap score is equal to 0. For a satellite channel narrotometer, the model expects a certain amount of nominal noise and gap work because your window is too clean or missing the character of the model flags it as a deviation from the expected magnetometer signature. What? So now being a nominal noise also is being flagged as anomaly because it's too clean. What kind of explanation is this? Duplicate timestamp. I noticed that your test and contain duplicate timestamp. Example 2 entries for okay. In two step in step 2 feature extraction, we calculate the second derivative to measure signal when 12 is of the same timestamp, the change between the mix process, the square derivative feedback explode drop to 0, which are both strong and negative sensor with why our scores are jumping to 0. To turn this into learning movement over clean, run at a subset time before passing data to injection loop. Okay, now I'll just take the whole code. Okay. Okay. First of all, I'll upload the necessary files here. Let me reconnect it, man. We are not on going to the root here, right? How it is detecting. Okay, we are connected. I'll upload the test and this one, and which was that? And there is one more, that is major project detection. What the fuck do you mean by that? And hmm. Okay, I think the root cause here is we need to first find how from our data set the model was actually trained. We need to visualize it. So identify how it's being, okay, never mind. Go back to Gemini. I'll just tell him, so give me the new code. And the path is code. Enter it. Okay, and let me see. I need to do some first of all strengthen some basics, man, before moving to next things. Okay. एक किलो किती म्हणजे तेवढं सांगितलं तेवढं आणलं थोडं छोटं बघे वार फिल्टर इग्नोर ओके मॉडेल बात ओके मॉडल साइज feature order step 4 knowledge of mapping okay okay it's knowledge of we don't need it but hey okay it's okay the order must be extend dot column exactly feature order knowledge graph def anomaly to hardware extract the live feature okay normal volatility geometric fix smoothing derivative main drive simulator loop drop loop duplicate timestamp okay we are good now let's say actually I don't think this will but yeah running them we are running them nothing is happening so far man um, mm-hmm. mm. Magnetometer 1 what is the channel anomaly detected hmm. What is our test and what is the data set we are using here बिर्याणी नको करू ग okay we are using the test and of course and it's telling me 30 I mean the scores are not pretty that good but hey okay I mean 49 seconds and detected anomalies I'm not saying okay we need to go to the root actually I don't know how it's ran it completely ran we took 3000 sample and out of which it only flagged how much auto elementary monitoring okay it's telling me now okay good I mean see we'll need to go back to basics I guess rushing model building and that ingestion is not the solution here we'll need to go to the basics here how did the model train uh, okay it is still identified many as anomalies while shouldn't shouldn't the shouldn't shouldn't it be blank? Why is it happening? Can you explore it in depth and tell me? Also tell me, how did we train our model? How did it identify anomaly? What was the procedure to do so? So I can then investigate further. So I guess okay, for we should increase the threshold. The percentage of this alert anomaly is challenge in time, especially when you're moving from static to isolation or more static and out of state. We must look at the statistic level. Okay, I mean, yeah. So we did a model for our threshold was 0.35. I guess 0.4 is a good threshold. What the fuck? Are we using threshold 0.4? Fuck up, man. We are using the threshold 0.4. Okay, I'm not using this one. Now let's run this again. – 27 seconds. Okay, 70 score. And we update the threshold anyway. Score was pretty high. Okay, but then the okay. Okay. Still, to resolve your nominal alert, you should look at the feature importance. It is likely that one specific feature level is much higher than your test ana.csv. That is in the training data, tricking the model into thinking it's an acceleration fault. Okay. So okay, I guess here I'll go to the word. I guess I'll go to the paint. I guess first thing we should optimize is I guess threshold. We should not. I guess threshold will be 0.4 for me. I guess 0.4. Was it 3 or 4? I mean, let me just see. Was it? What was the threshold here? Okay, 0.4 is good rather than then I think the window sliding window is equal to 160. Yeah, I guess we should reduce it. I don't know if I'm right or wrong. Okay, so it is telling me that model is being compared and all that, which is good, which is good. Now I'm going to do one more thing. I'll need to retrain the model. I guess I should retrain the model now. Yeah, for 50 epochs only, not 65. Okay. No matter how accuracy is low, because I guess the accuracy is the reason code here. I'm little bit overfitting the model. I'll train the model once again. Okay. I'll save that model, use that model here, and then check. Okay. Yeah. And then what's the another reason? What's another reason? Okay. No, it's telling me that the okay. Now let's go back to our anomaly detection. Okay. Um. Uh. Reconnect. Hmm. Hmm. There is one thing I know to know. This one. Are our scalar same every time we rerun the shell? Okay. Yeah, if our scalars are same, I guess they are same, right? Because the data is the same, then of course the scalars will be same, right? That's a good. Let me create one second. New installation. Every time you execute the work, a brand new standard object is created. So in terms of the object itself, it's not the same. Consider however, the critical button the line calculator the mean. If you extend hasn't changed then the calculator mean. So while it's in okay, in summary, if extend and the behavior of the scale will even the okay, so there is no need to rerun this cell again. Um, what I'll do is I'll create a new model, import TensorFlow. Hmm. Okay. Okay, I'll just do that. I'll create a new tab. I'll get a new file as well. Now we're going to build this model import. Okay. Extend scale. Okay, extend scale. Where is extend scale? There is no such. Where is this thing? See. Yeah, we'll see that. We'll see that, man. We'll see that. First of all, we'll just. This is my fucking mouse, bro. Anomaly. Anomaly model 2. Okay. Optimize. Where is this feature, man? Extend scale. I can find it. fuck? It's telling me they were not created, man. But I'm not wrong, we never use extend, bro. This is something called. No, no, something is wrong. I'll run this again. I'll run it again. Okay. Oh, I'm not running this again. Okay, let me check the Google Gemini code. I'm not going to trust this. Okay, now let's start from the first. What happened? Here. Okay. 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 Bro, what the fuck is this mouse? Okay, so we removed that line, yeah, and then we use the job done book. Uh, I want to retrain the model again. Okay, how can I use the generated scalar underscore v1 dot job and training it again? Okay, like what did we doing? Okay, like what will I do in model dot fit in the place of x train field. Okay, this is at the wrong place, so I'll remove this successfully. Okay, 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 it's telling me. I'll add this thing. I guess we missed this. And then something. Okay, now let's get started with our model 2 anomaly detection model 2. We'll first copy this cell and delete this. We don't want it, right? We want it somewhere here. Okay. That's where we want it. Okay, then we'll just say, okay, we'll go back. We'll call all the libraries because we need them. First, we'll upload our dataset. Number words connecting. Ideal. What? It's telling. Okay. Now it will execute. Let it take time. Till then, we will upload the file. Our dataset. I swear to God, bro, what the fuck is wrong with this mouse? Then we'll upload the scalar which we created. We are done. Okay, now let's start with our df. Okay, we will not do this. Is actually the exploratory data. Okay, we'll copy this cell again. We are ready, right? Good shit. Now we'll not do this. Actually, we already created the scalar. Import job import. Okay, import job loader. Extend scale is equal to x test scale. And why are we doing it? Transform. Okay, and we will build the model. There is no need to actually define the here's again, but we'll do that. Bro, then we'll feed the model. Okay. Okay. Batch size epochs, of course we don't want it to be epochs. I'll just use the 50th one, 50 epochs one. I'll make the model strict here. 45. Let's start with the 45. Model as validation, batch size equal to 34, purpose is equal to 34, and let's see if everything is good. Bro, what the, I swear to God, I need to use this again. It's increasing now. I created a feature and seems good. Then is this x-test scale. Okay, now we'll need to know what is x-test scale, and x-test scale is transform. Okay, I'll need to run this again. Where is that? Bro, please. I'm really sorry. Let me connect my mouse wire again. Okay, I don't know why it's being so randomly, but okay. Yeah, what was I thinking? Now, x-test scale. X-test scale, what is x-test scale? X-test scale is scalar dot transform. Let me just report this, reduce this. Yeah, x-test. Oh, what do I have to do is x-test is equal to scalar dot transform. Okay, I'll just do that. I'll do a transform. And download a scalar dot transform. X-test, if I'm not wrong. X-test is equal. And I am using 9201 MMCC. 9435, and the scores are okay, average. I don't know, I don't see anything. Seems like the training loss decrease immediately and the validation loss also did the same, but never mind. And we don't want anything, we already have it, and just save the model now. Okay, save the model now because we use that. Now we'll do with version 2. Okay, now I'll just say oh. Okay, what's it, bro? Oh, I'll download it. Now I will go to the live simulation. I'll copy this entire cell. Okay, and instead of it, I'll just upload my second model, version 2.1. The fuck is it? Downloads and download. And now we'll go back to our first thing, version 2. I'll save. Okay, scalar v1.job. We are ready, we are ready, we are ready, and let's see. How much took it second it to we'll just set it right. Oh, it's still executing. That's okay. There is no activity further. Okay, okay. This is good. This is actually good. If I just see that. Okay, let's see. Okay, let's see. Okay. Uh, okay, let's see this, and then we'll just go to the Excel sheet. We'll blank workbook. Oh, this is how. Okay, let me just see how it, what we did with it. I will just say I don't want this actually, and I didn't want this one as well. I'll just say anomaly detected. Good one. That's a good one. Yeah, let's say this is far better. I'll just copy paste that number of line. Forty-seven seconds. Oh my god, it's taking long. 50. Okay, that's it. Good. Now I'll copy those rows. How many time it took, man? Okay. Really? Yeah. Bro. Copy. And now let's go to the word then. It will be better, I guess. Man, like, what the fuck is this? Holy fuck. Okay. Good. 168. This is out 168 anomalies were detected. Okay. According to our new model. false positives. Okay, and then according to our old model, okay, I guess that is already lot. What did we use here? Threshold. I get threshold should be same in both the things. Okay, we use 4 as well. Yeah, I'll rerun the model. Okay, I'll just again, and I don't want this. Okay, let's see. What was again? Yeah, that was like 168 anomalies were detected. Okay, and in I'll see how many did we actually sent, how much columns were actually there, and out of how many were false positives. We'll now calculate the number of false positives as well. Well, you can use confusion matrix. Yeah, am I retarded or something? You can use confusion matrix. Why am I doing this manually? But never mind. Let's do this, because drawing a confusion matrix should contain both the anomalous and non-anomalous, and our test and our dataset only consist of non-anomalous. Okay, it's executed now. Okay, what's it? We'll go to again our thing. I'm again saying 5. Okay, and then again I'm just using okay, let's go back to our book 2 and print this. Okay, 168 now. 389. Okay, okay, 221 more false positives were detected. Okay, by our first model than our second model. Okay, I guess we can reduce this number, but I don't think we should reduce, right? And how many total were there anomalous out of test ana, which we, let's say, I don't convert, of course, out of test ana. Okay, out of 855, 168 were false positives. I mean, I'm really sorry, not only it should have been okay. So what was the history of the calculator? Once again, where's the calculator, man? History change. Let's well, let's minus. There is no history yet. Are you retarded? Uh, how, from where is this? 10, na? Okay, I'm really sorry. Okay, 389, 379 minus 168. 379 minus 168. 211 false positives were more according to this model. Oh, can we optimize this model more? Model 2. Okay. I mean, it's okay. It's okay. Our validation loss is increasing. Okay. I mean, let's see. uh, we need to read research paper again, I guess. The research paper, man. Research. Okay, I'll use the what do you say? I'll use the co-pilot, and then I'll say how did they actually train the model, and then we'll use that one. Okay, so we have version 2, version 3, and if necessary, we'll create a version 3 as well. Never mind. I'll take a 5-minute break. Are we alive? Let me check. Let me check. Let me check. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break. Wait, a 5-minute break. Let's take a 5-minute break.
assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to define them this. Question assignments if you have to
What the fuck? What the fuck was that, man? I should have. Okay. Okay, guys, we are back now. The stream is running, I guess. Yeah, it is. It is running. So now, I'll first of all I'll need to do is I'll open the notebook LM here. It's needed, right? Very much. And then I'll open the chat GPT and I'll upload this paper of that one. And which methodology, which so which how many neurons, batch normalization, how did they use? I will see this through this research paper. Yeah, this one. Okay. Okay, and the same goes for here as well. We'll open the okay, and I'll open the new notebook. Okay, I'll just say okay. I want to I want to train an anomaly oh, I'm really sorry, anomaly detection model using FCNN. In this research paper, it's clearly mentioned how to train the TRAI in the model. I have also used the same dataset. Your task is to give me how the CNN model is trained in this paper. Okay, and how did we train it? My model architecture, which I used previously, was okay. And at the time of fitting also we need to check it, how did they fit the model. This is not it. Okay, fit how much epochs, also 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 how did they fit. Okay, my fitting was okay. I'll just pause this and I'll open the upload file, the offset one. Open this, and then of course I'll copy this text. First let it be uploaded, the offset research paper, then we'll use the implement the same methodology and train our model, third version, and let's see. So far, now we know that threshold is 0.5. We have version 2, which was only run for 45 epochs. Okay, epochs. Now we can use early stopping, but there is no need to. I guess 45 epochs are, if you use early stopping, then 45 epochs should are minimum to at least train the model, right? So there is no point in using early stopping here. So I guess we have this 42 epochs. So now we will use the sliding window to see. A sliding window is 160. Okay, so we can change it. We can change the threshold, but uh, it also comes with one drawback, that if we change the threshold, some anomalies which are actually anomalies might get ignored, but so we will keep the ratio of false positive high. Okay, excellent. Now I will answer exactly according to not assumption. I carefully analyze the upside, and here is a total segment, training set 1, testing set, anomaly ratio वर गया. They did not use validate, unlike you. They use fixed training test plate and provided in the rest. They did not feed raw elements. They use 18 encrypted feature from वर्ग feature extraction वर्ग 12 raw and okay feature extraction, feature normalization, and training on day. They use binary classification. Okay, loss is equal to binary. Unlike typical ML, they did not focus on accuracy. They computed test set. Okay, universal detected. They ran two setup special detector. Okay, their serial perform. Okay, how did they how the model field paper operator? They did not have validation split. They did not randomly split during training. They use predefined TNP. Okay, model epoch is equal to 45. Batch size is equal to 32. What do you what you must load the data set and shift it using train column. Okay. Extra getting feature normal as train episode on the training set only. Evaluate only when tested. Only 18 and computed features. So almost our similar paper is there. We use the same number of people. Validation split, it doesn't make any much difference, and they did not use validation split, randomly split during training. Of course, neither did we randomly split. We already splitted the data set. So I guess we are good to go. I guess it's good. Why is it taking so much time here? I don't know. Okay, so we are good to go. I guess there is no need to version 3 and all, and there is no need to be early stopping as well. Okay, we almost use the same methodology. Okay, why is it taking so long, man? I just say, okay, yeah, it's now. It's now. There's a glitch in this notebook LM. Let's see. Notebook LM is I highly recommend because it's very useful. It really actually parses the entire contents of this research paper, and this also AI athletic based on. Okay, pretty much the same, I guess. Pretty much the same. I'll do that. Can we draw a confusion matrix on test data to see how our model perform? We already have test data as far as I know, right? Yeah, we have already. Bro, I just accept. I'll, there's no validation web tag. Where is the y test here? Y test, okay. Y plot. Okay. Actual 0 and predicted 0. I mean, yeah, this is good enough, right? This model is good enough. Okay, I guess we're done with the model procedure, as I guess. Okay, this version 2 is far good enough. I mean, okay, it's good, it's good, it's good. Version 2 is good. Version 2 is good, right? Yeah, version 2 is good so far. Bro, yeah. Okay, now I'll just say live simulation. You do something different earlier. Okay, we didn't use this. Use only 1, 2, 3, 4. Oh, what? Okay. Oh, what the fuck is this, bro? Okay, so it's correct. We are already we have used all the feature here. Smoothing derivatives, geometric normalize volatility. This one is good actually. This is the actual. Okay. Okay, now it's telling me to verify some of the needs here, like sampling rate. Okay, you compute duration is equal to length data minus into sampling. Make sure sampling rate is equal to time interval between sampling. Okay, let's see our sampling rate here, man. This is sampling. I'll upload this. I'll upload this. I'll upload this. And check if the sampling rate is we need to okay, I guess it's loaded. It's not? Okay. Why is it so? I may not say. Okay. Rolling average probability. We can do this. Okay, man. Okay, it doesn't take CSS files. One small improvement. I'll improve this in the Word first of all. However, window size. Okay, we have to. This one is the critical check. This one is the window size. Okay, these are the three suggestions we need to check first of all. I guess there are four. One, two, three. We uploaded. Okay, I guess live is hopefully going correct. Let's go. Okay, it's good. Everything is correct now. Okay, now we'll check window size. What our model was trained. That is the training, bro. What is the training? There is no such thing as window size here. Okay. There is no such thing as window size. So we are starting. We are normalizing. No window size. Okay. 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 Recall threshold. There is no such thing as window size. Okay. So about the window size. Okay. I guess we shouldn't use any such thing during training. I am attaching the Python. Yeah. What is that? Uh, Good. So we'll check that. We'll verify. He was telling me to use dflen.describe. Okay. I'll just use that anyways. I will use this in the version 2. Yeah, version 2. Okay. What the fuck? Okay, it's saying that 140 to 150 will more precisely align with the win. Okay, so let's see that. We'll use the 140. We'll use the 140. Let's see. Where is our live simulation? Windows sign, baby. 140, baby. Okay, 140. Let's see, 140. Good. Oh, man, it's actually good. Okay, it's going. Wait. Too soon to speak. And we'll analyze this. Was it 168? Wait, 2 for 3. Now I'll copy this and I'll just see how much was it actually. Okay, so we got 4 but I guess 140 to 150 is greater. So I'll basically use between them. I'll just choose 145 window size, right? Yeah, it's good. 145, good window size. 145, 145, very 145. I'll just go with as per the chat GPT. So I'll use the mid one, of course. 145. Where is it? Where is it? Live simulation, and I'll use the 145. So what are the things I need to know now? So the thing is, the threshold is 0.4. The sliding window is 145. Okay, version 2 model fits well. Version 2 model fits well. Sliding window fits well. Okay, there is no need to change that. Okay, if I'm not wrong, the threshold is correct. The thing is correct. Base normalization is correct. Everything is correct. The later live simulation is correct. Okay, good shit. One small change is there. So channel. That would be correct approach, but hey, we don't have anything else. Okay, I don't want. So we check the window size consistency. We got it. One small improvement. Add probability smoothing. Okay. Okay. I'll run this once again. I'll go with. I was told to add. Where should I add this in code? Okay. Okay, somewhere here. Probability smoothing is equal. Probability smoothing. I guess somewhere in this smoothing section, I need to add a probability smoothing as well. Why is this taking long? And what did it do? I'll just cancel this. I don't want it. I don't want this to disrupt the original code. Okay, this is actually retarded. Instead, I will just upload this. Okay, you told me to add probability smoothing. I have given you code below. Your task is to improvement and give me give it. Okay. Let's see. taking its time. Okay, let it take a time. I'll go have a sip of my I'm going to drink water. I'll come in 2 minutes. I'm back. Okay, so now let's copy this code, run this in the new cell, and see how this is different from our earlier cell. Okay, first of all, let's see if every feature. Okay, smoothing is there, derivative is there, geometry is there. I want to see if this is there. Okay, that's so many there. Okay, there is smoothing there. Now, where is the probability smoothing man here? Where is the probability? Which is there? Probability is there. If it's there. Okay, Q is there. More. Where's the probability smoothing, man? Where's the probability smoothing? Oh, map anomaly to graph direction. Feeds is there. Okay, we have the feeds. We have feeds. We have H ring. And where is the probability smoothing? Okay, it's adding. Okay, try. Okay, after ingesting left elementary data. Okay. Okay. D1 is there. So we have feeds is there, H there, P, the D1 is D2, feeds. Okay. It's okay after the probability. But I'm just saying this one. I don't, bro. I'm at it. Yeah, investing. Okay, investing live stream data, probability data, and feature extraction, anomaly detection. Okay, let's run this anyway. Again, I don't want this. Yeah, it's okay. Okay. Now it's better, far better. Again, I don't want this. Far better. Well, I think this is actually more. Let's see. Let's see if there's a tiny difference. Okay, good. It's doing different. It's detecting anomaly. I think this number is greater than 160. So we'll take again. We'll do the same procedure. I think this number is greater. Okay. Same method here. Control C. Go to our word in the 5th one. Okay. Bro, it's very high. It's very high actually. It's really high, and I know it. And Control C. I'm going to do it in the book 2. Okay. Mm. Confirm anomaly. Okay, it's good now. Same goes to you. Okay, now I. Okay. Uh, what's it? I'll take it one down because I want to add one row. Good. Now we'll just see. Okay. We'll tie with this is our header. Anomaly detector false positive. Okay. False positive. When was the false anomaly detected? Okay. False positive when version 2 model. Okay. False positive version 1 model. Okay. Good one. Here same false positive version 2 model comma as well as 145 sliding 140 sliding window. Okay. False positive version 2 model with smoothed probability mean. Okay, got it. Okay, let me just see. This is false positive version 2 model, and if the difference is 178 and 178 difference, the difference is the 8 one, and with okay, you can just see. Okay, false positive with smoother mean. You can see the least false positive where when the sliding window buzz. Okay, it's good. We have used the version 2 here, if I'm not wrong. Yeah, we have used the version 2 here. We have used the threshold 145. Threshold was same. Smoother window. Okay, that everything was same. Consistency check. Okay. 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 With typical ligament height, threshold is 0.4 and sliding window why did it add some extra sec? Like smooth number of recent probabilities to average. Okay. Okay, this is good. This is good. Then we had the version 1 on version 1, if I'm not wrong. A scalar, no, same. No, this no. No, this we didn't use. We use the model. I'm talking about the model, bro. Version 1, if I'm not wrong. The window size was 160, and yeah, this is not actually us. Window size was 160, There's a 140 and we use, what did we do here? We did we increase, I guess. What was the version here? No, I'm checking out the version. Which scalar? No, scalar v1. Yeah, version 1 here. Okay, then we use scalar v1 here as a test. We increase the window size and then we increase. Okay, this is good, good, good. Scalar v1. Bro, what the are you retarded? Of the okay, this is version 2, version 1. Okay, version 2 reducing the okay. Uh, then version 2 reducing the solution and then adding smoothing probability. Good. I mean, what is the test? And out of 855, 855, or out of 855, the false positive given are 169. Version 2 with nothing smoothing window. This was 165 with smoother probability. But I think there is no need for smoother probability, right? With smoother probability mean. I guess 140 is essential, and yeah, it's good. Out of so just like out of 806, somewhat is 800, 855. Ah, oh, out of 855, 170, 855, 170 were. So it's like 600, 650 were more. So it's good. I mean, you can use the version 2, I guess. You can use the version 2 here. There is no need for smoothed mean. This is alerting more false positive. We want this one. This is the great one. So I'll just mark it in my collab. Which one is the best? This is actually the best. Optimal choice. Okay. Again, this one. Optimal choice 2 with that. Oh, okay. So yeah. So we now have live simulation engine, live simulatory. Okay. Code. Now we have the model version 2. That's it for today, I guess. We have developed. Now we will combine. Now I will do this knowledge graphing. I will we have to edit what type of info we want, include the explainability here, more knowledge graph, and then we have to feed that to LLM and get our output. Okay, that is the next part, which we will do tomorrow, I guess. 26, we will do that tomorrow or today night itself, and then at the end we will come this all together and create a dashboard. Okay, so bye guys. Today we completed the model version 2, then this live telemetry ingestion. Okay, bye.